Hello and welcome to the cockpit of a Hawker Siddeley Trident, and this is a 4-engined, and I'll explain that shortly, airliner built in Great Britain last century. Now, while this aircraft wasn't a financial success, it did introduce a whole range of new and interesting design features, which I'll explain to you in this video, so let's get into it. I'm Paul Stewart, and I make videos about planes. This includes reviews of flights from around the world and detailed tours around interesting aircraft in museums. If you're into these types of videos, then please check out my channel and subscribe. And a massive thanks to the British Airliners Collection at the Duxford Air Museum for letting me film this aircraft. They've got a fascinating range of airliners on display, including the fastest Concorde ever, the Queen's plane, and many others. Before we have a look around this aircraft, let's start with some history. Short to medium haul flying was dominated by aircraft like the turboprop Vickers Viscount, and BEA, or British European Airways, had requested something bigger, resulting in the Viscount being enlarged to the Vanguard. Both of these aircraft will be featured in upcoming videos, so keep an eye out for those. But jet technology was moving quickly, and the French Sud Aviation Caravelle jet was up in the air, so BEA requested a new medium-sized airliner, also powered by the new jet engines. De Havilland proposed the DH.119 and the DH.120, which were quad jets and based on the Comet. Bristol proposed the Type 200, which had 3 engines positioned in the rear as a part of a T-tail. It was similar in size to the eventual Boeing 727. Avro, makers of the Vulcan, proposed the 740, which was also a tri-jet with this fascinating looking tail structure, and Vickers proposed the VC11 based on the VC10 under development. The sheer number of contenders vying for the contract highlighted how advanced the British aviation industry was. The world wars had obviously jolted everyone into action, and while the fighting had stopped, the Brits were making multiple breakthroughs with the first turboprop airliner put into mass production, the Vickers Viscount, and the first jet airliner, the de Havilland Comet. De Havilland proposed the DH.121. BEA accepted the 121 and the other proposals were all cancelled. De Havilland first planned the 111-seat DH.121 and that was complete. But then BEA decided it was too big and wanted it reduced to 97 seats. Its weight was reduced by a third, wingspan was reduced by roughly 17 feet, wing area by 30%, and the overall length by 13 feet. The Medway engines were replaced with less powerful Rolls-Royce Spey turbofans, but they did retain the cabin diameter. In 1960, de Havilland was purchased by Hawker Siddeley, hence why it was branded as that, and the Trident's maiden flight was on the 9th of January 1962, a full 13 months ahead of the Boeing 727's maiden flight. Now let's get into the tour. Starting at the nose, and what stands out is the offset nose wheel, which retracts sideways, and this is because of the especially large avionics bay sitting below the flight deck. In fact, we'll open it up shortly and stick our heads into it. Now, as an Australian, I'm not familiar with the concept of bad weather, but my British friends tell me that London Heathrow was often covered in fog, which would ground all of the flights. Therefore, a system where the plane could land itself in near-zero visibility was needed. Here's an early promotional video filmed during an actual landing, and you can see the Autoland system modulating both the yoke and the throttles, while the captain calmly talks to the camera. The plane has locked onto a beam transmitted from the ground, telling it how far to the left or right of the runway it is. Then at 1,000 feet, the Autoland takes over and the pilot becomes an observer as the system controls everything, including at 65 feet, the throttles cut back, and the nose automatically rises up for the landing flare. In 1965, the Trident performed the first automatic landing by a civil airliner on a scheduled passenger flight. Obviously, there was a lot of suspicion about such a system, so the avionics had a triplicated system for reliability, allowing a majority 2-to-1 voting system for guidance. So if 2 of the 3 computers were happy, they could continue the autoland, but if not, then alarms would advise a go-around. This equipment is quite bulky, hence the extra large avionics system, and the landing gear's offset position, and here's some of that equipment. Apparently the salespeople said that the offset nose wheel was because the autoland was so accurate that passengers would be disturbed as the plane ran over the runway center lights, but I'm not sure about that. Swinging back around and inside the nose cone was the radar, and here's an example of one of those from inside the plane. This device here was for the Flight Control's artificial fill system, which is an important system designed to stop the pilot from unintentionally damaging the control surfaces. Now in a small plane with manual controls, the pilot's control stick is directly linked to the control surface, so at a higher speed, the air flows faster and puts greater pressure on the control surface. This physically stops a pilot from making dramatic changes which, at high speeds, could actually break the control surface itself. But with the Trident and most large aircraft, the control surfaces are instead moved by 3000 psi of hydraulic pressure, and it won't be influenced by the aircraft's speed. So the pilot's stick is now connected to both the hydraulic system and this Q-pot, which has a piston inside of it which provides resistance that increases with airspeed. So now the pilot's stick moves against this, as well as the hydraulic system, so that it's given direct feedback to ensure that they don't overstress any control surface. We also see a British Union Jack flag and the logo for BEA. This was formed in 1946 with a few domestic flights within the UK, as well as Northern Africa, continental Europe and the Middle East. In 1974 it merged with BOAC to form British Airways. Now let's talk about the wing. Because this was a smaller jet designed to fly to less developed airports, ease of access for passengers and cargo was important, therefore having the fuselage low to the ground is a key design feature. Usually engines would sit inside or underneath the wings, but because these are all in the tail, the wing could remain clear, allowing both it and the fuselage to sit closer to the ground. The wing had a quarter chord sweepback of 35 degrees and was especially slippery due to the absence of engines, thus allowing it to be one of the fastest subsonic commercial airliners, cruising at over 610 miles an hour or 980 kilometers an hour. While slippery, the wings wouldn't create great low-speed lift. In fact, crews would nickname it the ground gripper because it seemingly would grip the runway and wouldn't want to rotate. Another joke from pilots was that it required the curvature of the earth to lift. To help with the low-speed lift, it was fitted with these extendable trailing edge flaps, as you can see here, although they could only do so much. Another issue with the wing sweep was the risk of air sliding sideways rather than directly moving over the top, so they installed these wing fences and that forced the air to move from fore to aft rather than laterally. The forward section of this fence actually moved down with the leading edge slats as well. Looking down at the main landing gear, and you'll see it's in a regular tricycle layout, although the main gear is novel because it has 4 tyres on the same axle instead of the usual 2. These spread the weight over a larger surface area, which was useful for less developed airports, where there was a risk of being too heavy and sinking through the tarmac. It also took up less space within the fuselage when retracted than a regular 4-wheel bogie. This layout also allows for a smaller turning circle and avoiding tyre scrubbing. They also rotated when folding up to again take up less room once in the air. There were fans within the brake hub to speed up the cooling process and increase the turnaround speed. As we saw with the Boeing 727, the 3 engines was a compromise between the safety and thrust of 4 engines versus better fuel economy of 2 engines. BEA requested, quote, more than 2 engines, and the manufacturer felt that 3 engines would be safer during an engine failure during takeoff. In fact, each of the 3 engines would drive its own hydraulic system, offering triple redundancy in case of any of the other engines failing. The central engine is positioned in the tail cone and level with the other 2, but has a higher S-duct air inlet, hence why it looks higher than the other ones. Looking here, and we have the thrust reverser. Now remember that the wings were so sleek that they didn't produce much drag, so this really wouldn't slow down very well. So the thrust reversers could be activated in flight to help expedite the descent. The Trident 1C had the unusual ability to use these just before touchdown during the flare, and the pilot could decide if they would idle the engines or even use full reverse thrust. The idea was that this would help avoid hydroplaning and reduce landing distance on slippery runways and preserve the wheel brakes by keeping the temperature low. The brakes were also fitted with an anti-skid system, and the main landing gear was also strong enough to be lowered to create drag and slow the plane as it descended. Check out my Boeing B-47 guided tour video, as they had a similar problem slowing the aircraft because its design was inherently so slippery. They would release a drogue parachute and drop the rear landing gear at altitude to help it descend, but I digress. While the 3 main engines were Rolls-Royce Spey low bypass turbofans, the 3B version had a 4th booster Rolls-Royce RB162 turbojet to help move the heavier and larger fuselage during the takeoff and climb. It was connected with engine number 2's throttle and cut out at 10,000 feet and be off for the remainder of the flight. This was a cheaper alternative to upgrading the 3 main engines. It produced an extra 5,250 pounds of thrust and specifically developed in the 1960s as a lift engine for the planned short takeoff and landing aircraft. It was a joint program with the Brits, the Germans and the French, and was the first turbojet to use composite fiberglass compressor casings and plastic compressor blades to reduce weight and production costs. While the engine was considered to be a success, V-style aircraft weren't, with the Dassault and Dornier DO-31 programs being cancelled, so the Trident III was actually the only production aircraft to ever use this. It was positioned here, and this panel would open up on the side to allow air in, and then close once it was turned off. This is why I mentioned 4 engines in the intro, but I was mostly just being a little clever, as the rest all had 3 engines, hence the name Trident. But just to complicate this sentence even more, it did have one final engine, an auxiliary power unit. Remember that unlike the Boeing 707, which was fully reliant on ground power units to start their engines, and that was usually okay because it would operate from large and developed airports, but this was designed to operate out of small airports, so they wouldn't necessarily be able to rely on ground power sources. This smaller power unit could start the main turbofans as well as operate the onboard systems while on the ground. It was initially positioned in the aircraft's belly, similar to where the 727 positions its APU, and here's a photo under a Trident. But they found that it was directing too much heat down onto the tarmac, causing damage. As a temporary fix, they used an exhaust diverter, which moved the heat up and away, but obviously this wouldn't be ideal, adding yet another piece of equipment to the inventory of smaller airports. So they moved the APU to the tail, but in different positions depending on the model. In the 3-engine Trident 1 and 2, this was located here, and the air inlet above engine 2 was for the air conditioning system. But in the Trident 3, up here, was the APU and the APU air duct. The high positioning of the engines also kept it up and above foreign bodies on less developed runways that could otherwise be sucked up into it, again contrasting this with the engine sitting underneath the wings on the 737. In fact, the 737 had a special gravel kit with this guard over the nose wheel to help reduce the risk of foreign bodies being kicked up by the wheel and into the engine. But negatives of a high position were that they were more difficult to reach for maintenance, as you'd need ladders and scaffolding to get anywhere up near them. This device here on the exhaust pipe was part of a hush kit designed to reduce the noise it produced, but apparently it wasn't that effective. In fact, it was noise pollution rules that essentially killed off this aircraft in the UK. Now, obviously positioning the engine at the tail meant that their horizontal stabilizer would need to be raised, resulting in what became known as the T-tail. I'll mention more about this in my BAC 111 video, but a known risk of this design was where during a high angle of attack, so the whole aircraft is angled upwards, the air moving past the fuselage is now blocked by the underside of the wing, therefore none is going to reach the elevator at the tail, so it's impossible to lower the nose. Usually the elevator would do this, but it's completely shielded from the airflow. After a near crash of this during testing, and the 111's crash during development, these were fitted with stick shakers which violently let the crew know that a stall was imminent by, as the name suggests, shaking the control stick. They also had very loud audible alarms, as you can hear, and the control stick is shaking here too. If these warnings were ignored and the control stick wasn't moved forward, which is the usual way to manage a stall, there was a pneumatic ram which would physically push the stick forward. Hopefully this would avoid reaching the high stall in the first place. Another advantage of the engines being positioned so close to the aircraft centerline is that, in the case of an asymmetric thrust due to an engine failure, it would be easier to control than if the engines were further out on the wing, meaning that a smaller and lighter fin could be used. Now as we walk under the wing, let's look at some patches over bullet holes on this particular aircraft. In June 1973, it was loaned to Cyprus Airways. It was parked at Nicosia Airport when Turkey invaded in 1974, and it was hit by several bullets from Turkish Air Force Super Sabres. It was abandoned on the runway until some BA engineers flew over to see what could be salvaged. It was then flown back to the UK unpressurised and repaired with these patches. It then went on to fly the inner city shuttle services until March 1982 when it was retired. In 1990, it was repainted in the original BEA red square livery, which I think looks brilliant. This marked here as hot was a drain mast. Onboard fluids could be released here, but remember that at cruising altitude it would be minus 50 degrees Celsius outside, so any water would freeze at the tip of this mast and block the flow. So they'd have to heat up the water to stop it from immediately freezing. And here's another patch over another bullet wound. Now keen observers will realise that this looks strikingly similar to the Boeing 727. Now in the late 1950s, Boeing was looking into a trijet, and they had the option of designing their own, which ultimately they did, or do a deal with the Brits to build this aircraft over there. The Brits invited Boeing engineers and executives over and revealed essentially every detail about their planned jet. Boeing also invited the Brits over there, but apparently little information about the 727 was provided. It really was a bizarre home goal, where sensitive proprietary information was given to a direct competitor. I'm sure Boeing were excited to hear that the Trident was going to be too small, and their larger 727 went on to be an incredible economic success. Now let's head inside this incredible aircraft. We'll check out the cabin and finish up in the cockpit. As with most airliners of the day, until the 747 arrived, this had a single central aisle, where seats were in a 3-3 layout, and this had a capacity of 115 passengers. It was actually first planned to have a 2-3 layout, much like the 707 actually, but stretched to fit in 6 across. In fact, Channel Airways tried 7 across, which would have been very tight and uncomfortable. It's a much older style of seat, with thick cushions and obviously a lot more legroom. Now people often like to romanticise how travel used to be, where you'd dress up in your Sunday best, drink champagne and smoke cigars even in economy class. But what everyone seems to forget is that the price of an economy ticket was the equivalent, once adjusted for inflation, of a first class ticket now. So people really need to stop comparing current economy tickets to old first class tickets. If you want a fair comparison, compare these with the new fold flat with doors first class suites, and then you'll see that flying is actually much more comfortable now. By the way, if you enjoy these types of videos, then consider becoming a channel supporter. I'll be honest now and admit that you get absolutely no perks other than knowing you're helping me create more of these videos. Click on the join button below. But I understand if the finances are a bit tight at the moment, so in that case then just please give it a thumbs up because that costs nothing. Down here on the right are 2 devices. Above is a circular weather radar scanner from inside the nose, and the rectangular device below is a Doppler aerial positioned underneath the aircraft, but could also rotate nose up and nose down. It gave the pilot ground speed and drift angle information and was involved with the moving map that I'll show you in the cockpit. Moving back towards the front, and we have the galley, the crew seat position and another door. Obviously, as passenger numbers increased, more exits were required to speed up evacuations. Of interest, the reason why the Vickers Viscount had such large windows was not to give the passengers a good view, but instead because each window was originally planned to be an emergency exit. But in the end, they just needed a few of them as exits as government regulations changed. Looking up, and you've got the coat and bag racks. One advance with modern airliners are much larger overhead luggage bins. Moving forward and past the main doors we entered through is a toilet which, I will admit, is bigger than the current ones, and on the opposite side is a galley where the meals would be made, and there was another exit door as well. Then we're into the cockpit, which was surprisingly bright and spacious. There was increasingly greater recognition of pilot comfort, which really was a safety factor, and more space would contribute to this. Check out my Avro Vulcan or even the Comet 4 videos if you want to see some very uncomfortable looking cockpits. On the left is an observer's position, and in front of them was the captain's chair. Here on the left we have the circular device, which was the nose gear steering wheel. In front is the ram's horn control column, which is mechanically connected to the co-pilot's column, so each pilot could feel each other's input, which is important to know during an emergency. In the center was an advanced moving map display, and while it was still paper, it was far more reliable than other similar systems. The Comet's Decker system, for example, was notoriously inaccurate, as the signals from the ground bases would be distorted by the curvature of the Earth. This electromechanical device in the Trident used a Doppler navigation system that could accurately read ground speed, drift, and heading data. It would then feed that information into the system, and the pointer would move laterally, allowing the crew to follow a set route as the paper slowly scrolled past it. It originally had a pen on the pointer that would draw a line on the paper map showing the route it had flown, although then the map couldn't be reused, so they got rid of that. This could cross the Atlantic Ocean simply by steering based on keeping the tracing pen on the pre-designated course. In the middle are the 3 throttles easily within the reach of both pilots or the flight engineer. That down there is the controls for the auto-land system, which you might recall from seeing earlier in this footage during the landing sequence. And looking down here, we have the flap and slat controls, which used to look and feel the same. In 1972, 118 people were killed when a Trident crashed shortly after takeoff. A crew member reached here to withdraw the flaps, but instead accidentally withdrew the leading edge slats. Lift was dramatically reduced, and the plane entered a stall which was unrecoverable. One of the recommendations from the investigation was that nearby controls should be physically different shapes to reduce the chance of a crew member touching the wrong one. While the Trident was the first airliner fitted with a quick access flight data recorder, a voice recorder was also added after the investigation due to concerns about conflict between the pilots being a contributing factor. And looking over at the starboard seat, which is where the co-pilot will be sitting, and the controls are repeated over there. Here's a quick look at the Mach meter, which did go to 1.0, as remember, this was a fast aircraft, although not quite supersonic. And this was due in part to the slippery wing, which was great at high speed, but generated poor lift at low speed, hence the tendency to stall in the aforementioned crash. And spinning back around, and we finish off with the 3-person flight crew with the flight engineer's position. This position was computerized with modern airliners, although back then they would be closely monitoring the engine parameters and fluids. The British and Cyprus Airways replaced this guy with another pilot who would swap after flight segments. There were 5 different Trident variants built. There was the original Trident 1C, which was the first production version, and 24 of those were built. The 1E, with E standing for extended range, and 15 of these were built, had an increased seating capacity, uprated engines, and leading edge slats were added to improve low-speed performance. Next was the Trident 2E, which is what this type is, and developed in response to request for a longer range to BEA's distant corners of their network, such as Beirut in Lebanon. They kept the Trident 1's fuselage, but installed a larger wing with leading edge slats instead of the earlier droop flaps, and added fuel capacity, including a 350-gallon tank in the fin. It also came with uprated Spey engines, which were the final derivative of this engine to be used in an airliner. They produced 560 pounds more thrust than the engine fitted to the Trident 1E, allowing it to have the same cruise speed even though it had an increased weight. Its range, fully loaded, was 2,475 miles, which was considerably further than the 1C's 1,000-mile range. It was also the first variant with the full triplex autoland feature. BEA ordered 15, although the largest buyer was China's CAAC, which stands for the Civil Aviation Administration of China. They didn't install the autoland in theirs and instead had 2 more crew members, a navigator and a radio operator. Here's an additional station in the cockpit, and the idea of the radio operator was to help communicate with English-speaking air traffic control when many Chinese pilots would have had limited English back then. They also had different control columns, as you can see here, which I suspect was to improve crew familiarity by keeping their fleet as similar as possible. There was an interesting incident in 1971 involving the vice chairman of the Chinese Communist Party, Lin Biao. Apparently he was attempting to defect to the Soviet Union after a failed assassination attempt on their leader, Mao Zedong. One of these aircraft crashed in Mongolia, and both Lin and his family were on board. There's dispute about the cause of the crash, with officials saying they ran out of fuel, while that's contested by quite a few others. Obviously, fuel starvation is quite an unusual cause of a plane crash now with advanced technology, even in the 1970s. 50 of those were built. Next was the Trident 3B. In 1966, BEA announced a requirement for an airliner with a longer range and more seats. The government did not approve the initial plan to operate Boeing 737 and 727s, so Hawker Siddeley proposed the Trident 3B, which was 16 feet and 5 inches longer, and fitted with a boost engine I mentioned earlier. The APU had to move just forward of the vertical stabilizer, and the fin-positioned fuel tanks were removed. Of interest, the Trident 3 was now similar in size to the original plan and closer to the 727 size, but this time the Boeing trijet was well established and dominating the market. While BEA initially wanted a smaller plane, the international buyers all wanted more seats, hence its limited sales. And the final variant was the Super Trident 3B with an extended range of 413 miles, but only 2 of these were built. But interest was drying up and it was impossible to compete with the established 727, so production stopped in 1978 after only 117 were built. This was in comparison to over 1,800 727s built. In 1986, the Chapter 2 noise regulations were introduced and the Trident did not meet the requirements. The engines would need to be changed or hush kits added, but this was decided to be unviable, so the Tridents were phased out. These devices here were meant to reduce the sound, but they didn't do much. BAs retired theirs in 1985, but they kept flying in China until 1995. This whole story really was a lesson in not focusing a product on a single airline's requirement, as clearly BEA did not know what they were doing. And also, don't give a competitor access to specific details of your product until contracts for the collaboration have already been signed. Once again, this was an example of great British engineering let down by the suits at the top. I'd love to hear your thoughts. Did Boeing steal de Havilland's design? Would the original and larger sized Trident have sold any more, with both American and British airlines seemingly having a preference for Boeing anyway? Join me in the discussions below. If you enjoyed these videos, then please give it a thumbs up and check out my channel. I've got a whole range of videos coming, including a tour around the BAC 111, the Viscount, the Vanguard, the Monarch, and more. Thanks for watching.